Audio Jungle. Audio Jungle.
Hello everyone, myself Naren Singh Maurya. So today we'll solve GATE 2019 rocket propulsion problem. Here we have problem number 45. So for a rocket engine, the velocity ratio R, which is nothing but VA by VE, where VA is the vehicle velocity and VE is the exit velocity of exhaust gases. Assume the flow to be optimally expanded through the nozzle for R is equal to 2 if F is thrust produced and M is the mass flow rate of exhaust gases, then F divided by M dot VE. Alright, so check. Okay, this is the rocket here. This rocket velocity exit is nothing but VE, and this rocket forward velocity is nothing but VA, vehicle velocity basically. And you know, we'll have a obviously propellant inside the combustion chamber. So this is what propellant. This propellant is what burning. So we are getting M dot P, mass flow rate. Okay. They have given velocity ratio, and that is denoted by small r. What is the velocity ratio? They have said vehicle velocity divided by exhaust velocity. All right. Now this exit pressure is what PE, and here this is what atmosphere PA, ambient pressure. So what is the mean of the optimally expanded? Optimally expanded case, that mean is it is expanded to the ambient pressure. So PE becomes PA. That's the mean of the optimally expanded. You know all three types of expansion in nozzle: over expansion, under expansion, and optimal expansion. So optimal expansion means expansion of the hot gases from the combustion chamber through the nozzle to the ambient pressure, and ambient pressure means atmospheric pressure. This is what ambient pressure. They have clearly mentioned assume the flow to be optimally expanded through the nozzle. So F is the thrust. We'll write the thrust formula for this. Thrust is nothing but M dot VE plus AE PE minus PA. It is optimally expanded, so this part will be 0. Why? Because optimally expansion means PE is equal to PA. So we got F is equal to M dot V. F divided by M dot VE is equal to what? 1 here. So now the speed ratio is what? Suppose R is nothing but VA by VE. Earlier they had given R is VA by VE, that condition they had given, that is velocity ratio, and now they are saying R is equal to 2, means VA by VE becomes 2. Okay. So if R become 2, and for this they are asking force by thrust force divided by M dot VE value. So what is the mean of this? R is equal to VA by VE, VA by VE is equal to 2. So what is the mean? VA 2 times of VE. Means vehicle speed becomes 2 times of the exhaust speed. So what will be the F by M dot VE? Check this F by m dot ve depending on the velocity now anymore? No. Only one velocity component ve, but if you are taking ratio, so it becomes 1, which is nothing but constant independent. All right. So now doesn't matter. It is va is equal to 3 ve or va is equal to 4ve or va is equal to n times of ve. Doesn't matter that this value will not be changed. This value will be constant, independent means constant. What is the value finally? Constant value, it is 1. It is not going to change. It is r is equal to 2, r is equal to 3, r is equal to 4, doesn't matter. Hope you understood. So this value will be 1. Doesn't matter r is equal to 1, 2, 3, 4, 5, anything. Hope you understood. Alright? Okay. Now this is the next problem, problem number 46. The specific impulse of rocket engine is given 3000 Newton second per kg. Okay. The mass of rocket is burned out is 1000 kg. The mass of rocket at burnout is 1000 kg. All right. The propellant consumed in the process 720 kg. Assume all factors contributing to velocity loss to be negligible. There is no velocity loss, no gravity loss, no drag loss. The change in velocity delta u is in kilometer per second. They are asking. Hope you understood this problem. See, very simple. For the I will draw the diagrams. It will be more clear. Okay. Now here in this rocket, we'll have a propellant also. This is the propellant. Okay. Now, what data they have given to us? They are saying the mass of rocket at burned out is 1000 kg. Means after the burning of propellant, what is the mass? It is, you better you say mf. Mf is the final mass or mass of the rocket at burnout. That meaning is same. MF or I must say MB. MB means after burning out, what is the mass of the rocket? That value they have given to us, it is 1000 kg. Okay. This is the propellant. Hmm? The propellant consumed in process, how much propellant is what consumed? 720 kg. This amount is what consumed. Okay. Assume all factors contributing velocity loss to be negligible, change in velocity. So what is the initial mass? Initial mass, at the time of lift off condition, what is the initial mass? It is the total mass. Initial mass means total mass. Okay. Total mass means what? After burnout means mf plus propellant mass. So initial mass denoted by m naught. Mf is nothing but 1000. Burnout mass plus 720. How much? This is the initial mass, 1720 kg. All right. They are asking change in velocity. So this is the formula. Okay, that you should remember. This is the derived formula. Change velocity, or sometimes it is called incremental velocity. So that is delta U. What is the formula for this? ISPG ln m naught by mf, or it is also V effective ln m naught by mf. This is the formula. Check effective velocity or ISP, something they have given. They have given impulse, specific impulse, but again the problem is what unit. What is the unit they have given is specific impulse? 3000 Newton second per kg. I want to convert it into second. So what we'll do? We'll write 3000, because mass into gravitational acceleration will be Newton. So Newton cancel. So better in denominator we multiplied by gravitational acceleration. So gravitational acceleration into mass becomes Newton. So Newton by Newton will be cancelled out. So I will multiply it by 9.8 in denominator. How much? Why I am converting always? Even you can keep this way also, but in formula you need to remember this. That's the point. But what I used to do, I just convert. Why? Because standard formula it is ISP in second. So I always used to convert this into second, so that there should not be any confusion. 1 to second. So this is what is standard formula. So here this ISP is what in second. How much I got? Is 306.12 into G is nothing but 9.8. Check. G is given, it's okay, otherwise you can take 9.8. Okay. Ln, what is the initial mass you have calculated? 1720. What is the final? It is 1000. What is the delta U? Let me calculate. 9.8 into ln, okay, into ln 1720 divided by 1000. I'll get 162.6.9 meter per second, okay, or 1.62 kilometer per second. Okay, this is the formula. This is the remark. Remark means you need to remember this formula. Okay, this is the derived formula. Even in like in my lectures, rocket propulsion lectures, it is derived. Okay, so you can go through the derivation. Otherwise, you just remember the formula in rocket propulsion. What is the change in velocity or incremental velocity? I have written this change in velocity or incremental velocity in both format, in effective velocity terms of effective velocity, as well as I have written in terms of ISP. All right, so you remember this formula, and it is m naught by mf. Okay, always remember. So this delta u is 1.62 kilometer per second. Here I will keep this value. Kilometer per second, so 1.62 only you have to write. 1.62. That's this is your answer actually. All right, so keep doing hard work always. Thank you so much. Thank you all.